Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so question 1 asks, a 0.10 molar sodium chloride aqueous solution has a higher boiling point than a 0.10 molar magnesium sulfate aqueous solution. Explain why. Okay, so notice that both the sodium chloride and the magnesium sulfide solutions have the same concentration. So that means that in order to figure out why one has a higher boiling point than the other, we need to look at something called the Van Hoft factor. Okay, so I'll just write out how it's spelled. So the Van Hoft factor is the ratio between the actual concentration of particles that are produced when the substance is dissolved and the concentration of a substance, so that same substance, that is calculated from its mass. Okay, so again, it is the ratio between the actual concentration of particles produced when the substance is dissolved and the concentration of a substance calculated from its mass. So it can be expressed using the following formula. So that is an alpha. So here, I is equal to the Van Hoft factor. Alpha is the degree of dissociation. N is the number of ions formed. And over here, if you look at the junior tutor's answer, they have just a table of the expected and observed values of the Van Hoft factor for 0.05 molar solutions of several electrolytes. So they have it for different electrolytes like sodium chloride, magnesium sulfate, iron chloride, hydrochloric acid, and glucose. So they said from table 11.6, magnesium sulfate has an observed Van Hoff factor value of 1.3, while the observed value for sodium chloride is 1.9. Both salts have an expected value of 2. The expected Van Hoff factor value for a salt is determined by assuming 100% of the salt breaks up into separate cations and anions. The magnesium sulfate solution is furthest from the expected Van Hoff factor value because it forms the most combined ion pairs in solution. When sodium chloride is in solution, it has very few combined ion pairs and hence has a Van Hoff factor very close to the expected I value. So this is the reason why it has a higher boiling point. So boiling point elevation depends on 3 variables. The boiling point elevation constant of the solvent. So in the question, they are both in aqueous solutions, so that means they have the same solvent. The Van Hoff factor of the solute, so we can see here that they got different factor values, and the molality of the solution. In this question, molality is held constant. Yep, so I can verify that this solution is correct.